In an earlier segment, we talked about random samples, and we'd like to define random sample a little bit more carefully at this point. A simple random sample is what we're talking about, and a simple random sample has basically two aspects to it. One is that every member of the population that the sample is drawn from has an equal chance of being selected for the sample. And also, every sample of the same size has an equal chance of being selected. You see, there are loads of samples of the same size. If you have a population of 10 million and you're taking a sample of 200, there are an awful lot of groups of 200 that can be selected, you see, from that population. And so every one of those samples needs to have an equal chance of being selected. An interesting story related to this is the notion of ranchers out west that were having trouble with the coyotes eating their sheep. And it was determined, because several ranchers, maybe many ranchers, had this problem, that the coyotes should be eliminated altogether. Well, some of the coyotes were eliminated. That is, the federal government stepped into the situation and decided to poison a certain portion of the population of coyotes, thinking that that would eliminate the sheep loss situation. Well, after the coyotes, a certain portion of the coyote population generally was poisoned, it turned out that the reduction of sheep did not follow. And it's because the sampling that was done to determine that the poisoning should occur was not a sample that would be a simple random sample. You see, one rancher would say, gee, I saw 5 coyotes eating my sheep. Another rancher says, I saw 5 coyotes eating my sheep. Another said, I saw 5 coyotes eating my sheep. Well, those were 3 samples of 5 coyotes. Now, we defy both of the aspects of simple random sample here because of the, let's say, the first rancher's 5 coyotes. Were those 5 coyotes a general sampling of the population? That is, did every member of the coyote population have an equal chance of being selected for that sample? No. And what about the notion of these samples of 5? You see, we have a sample of 5 here, a sample of 5 here, a sample of 5 over here. Were, out of all of the possible samples of 5, were these equally as likely to be selected as all of the others? Well, certainly not. You see, it turns out that particular coyotes have a taste for sheep, and other coyotes have no taste for sheep, don't care to eat sheep. And this is what was happening in that situation. So by eliminating a certain percent of the population generally, the sheep-eating part of the population were still eating sheep, you see. And to solve the problem, we have to identify those coyotes, those particular coyotes that like sheep, and eliminate those from the population, not the entire population itself. Well, this is a good example of how not to make decisions on a sample unless the sample is indeed random. Another example of what not to do in sampling is this. These are a couple of other faulty methods. Suppose we want to sample the population of a big city like Atlanta for a survey about age. So we're going to survey people about age. And we select every 3rd person leaving the women's department of an upscale department store. Now, what's wrong with that? Why is this would this be a biased sample? Well, if we're selecting people leaving the women's department of an upscale department store, if it's the women's department, then presumably we're going to be surveying more women than men, perhaps only women in this survey. A bias is built into that situation. If we're talking about an upscale department store, then that probably puts the people coming out of that department into a certain income bracket. They would be in a higher income bracket than the population generally. you see. And again, if we're talking about an upscale department store, then probably we're talking about a greater portion of those individuals being of an older age than the general population might be. Suppose we're talking about a survey involving income from the same group. Well, the same biases hold true here. We're talking about a gender bias, you see, involved with the women versus men. We're talking about a bias involved with age and income for this kind of survey. So that's what not to do. Now, what do we do in such situations? Well, one thing is that if it's possible to associate the members of a population with a number, and we assign a number to all of the members of the population, a different number to all of them. And if we're able to choose numbers randomly, then we could select our sample in that way. We could use random numbers to select from a population, select a sample from a population. Now, random numbers are not just numbers that you or I would make up. They are numbers that are generated randomly by a machine. They could be generated by us if we, for example, took, let's say ping pong balls. And we take 10 ping pong balls and we label one with a 0 and one with a 1 and another with a 2 all the way up to 9. So we have all the digits 0 through 9 represented in these 10 ping pong balls. And then we put the ping pong balls in a hopper and we put a blower on the hopper and we blow them around and so forth, and we reach in and we grab one at random. And then we look at it and we read the digit and we record that digit. Then we put that ping pong ball back in because we want that one to have an equal chance of being selected on our next draw, and then we let them mix a little bit. We reach in and we grab another ping pong ball, we read its digit and record it, you see, and in that way we can record digits randomly for as long as we would like to do. Another way, somewhat easier, is to use a random number generator within a calculator or a computer. Or we can even look in a table. There is such a table in the back of your textbook. Let's have a look at that. Now, here's a random number table. Now, this table, you can't see the entire table, but this table consists of 50 rows and 10 blocks. Now, the rows go left and right, and the blocks go up and down. Now, if we were going to select a random number or select random numbers, we would start at some place in this random number table. And let's just say that randomly we may blindfold ourselves and point at the table, and let's say that we select the 17th row, 4th block. The 17th row, well, we would count from the top, 5, 10, 15, 16, here's the 17th row. Then we go over to the 4th block, 1, 2, 3, 4, 4th block. All right, then we start with the digits 0, 8, 1, 9, 1, and then 8, 9, 4, 2, 0. And we continue to write down as many digits as we need, and I've recorded them here. So 0, 8, 1, 9, 1, 8, 9, 4, 2, 0. So right from the table, 6, 7, 8, 0, 0, 5, 5, 1, 3, 7, and so on. And we can continue this. Now notice that I'm writing these digits down left to right. We could select to write them down up and down, or diagonally from the random number table if we want to. But here's how this kind of table might be used to select a random sample. Suppose there are 500 automobiles and we want to select 30 of them for some kind of sample. 500 automobiles. Well, we could assign a number to them. We could put a number on the windshield of them, 1 through 500. And then here's how we would use the random number table to generate random items from that group of 500 automobiles. Now, you know that 500, numbers 1 to 500, the 500 is a 3-digit number. We can think of 1 as a 3-digit number also as the number 001, you see. So this is a group of 3-digit numbers, so we could take our random numbers here and divide them into groups of 3 digits. So this would be 081, and then 918, and then 942, and then 067, you see, and then 800, and so on. Now, we just record many of these, and then we say to ourselves, well, let's see, this would be, 081 would be number 81. And this is number 918. Oh, our numbers for the automobiles only go from 1 to 500. So we eliminate this one. 942, we need to eliminate that one. 067, oh, that's number 67. 800, we eliminate that one. You see, any of them beginning with a digit of 6, 7, 8, or 9 need to be eliminated. But in this way, we could select randomly a sample of 30 automobiles from that list of 500. If we were, for example, selecting 15 members, a sample of 15 members of a class of 80. Now, if we want 15 members of a class of 80, 80 has 2 digits in it. So we are assigning a number to every member of that class of 80. So we're assigning numbers 1 through 80. Those numbers are associated with names of people. And so what we would do with our random number generator, if we were starting with the 17th row, 4th block, then we would presumably write these in groups of 2 digits. So it would be 08, and then 19, and then 18, and then 94, and then 20, and so on. And now items 8, 19, 18, 94, oh, 94 is not within that group of 1 through 80, so we eliminate that. 20, you see, and so on. We continue that process until we have the 15 that we're after. We could even associate this random number idea to something like an experiment having to do with the roll of dice or the flipping of a coin. You know, if we're thinking about probabilities involving the flipping of a coin, then coins can either be heads or tails. So we could assign the heads idea to a, well, let's say an even number, and the heads idea to an even number, and the head then the tails idea to an odd number. So we got to have the even and odd number situation associated with heads and tails. And in that way, we can say that, okay, let's record this experiment of flipping coins by using the random number generator. We would say, oh, an even number, heads, heads, odd, tails, odd, tails, odd, tails, even, head. You see, so in that way we could record the same thing as flipping a coin as many times as we would like to using the random number generator. So there are a lot of ways to use it, a lot of situations where we can use it, and it gives us a fair and proper simple random sample. There are other kinds of sampling techniques. We're going to talk about 4 other kinds of sampling techniques here, and I just want to describe them to you, but we're not really going to study them in this course. I just want you to know that there are other techniques. They're kind of beyond the scope of this course, but I just want you to know what they are. One of them is called a stratified sampling. Stratified sampling occurs if you can take the population and divide it into strata. Now, strata is the plural of stratum. But stratifying a population is kind of like having let's say a high school class. All of a high school can be divided into freshmen, sophomores, juniors, seniors. You see, so we're stratifying the entire population. If we want a sample from the population, then we could say, okay, we have so many freshmen, so many sophomores, so many juniors, so many seniors. Now, let's divide it that way. Now we'll sample within the freshmen, within the sophomores, the juniors, the seniors, and presumably what we would do, depending upon what we want in the kind of survey, you see this can get a little bit complicated, but depending upon what we want in the survey, suppose we know that the freshman class is significantly larger than the other classes. That is, let's say that the freshman class, instead of representing 25% of the overall population of the high school, they represent 40% of the overall high school. So in this overall sampling that we're taking from the freshmen, sophomores, juniors, and seniors, perhaps 40% of the overall sample should come from this freshman class. You see, that's kind of an advantage of doing it this way. You're making sure that 40% of the sample comes from that freshman class because that's how they're represented in the overall population. So stratified sampling, that's what that's all about. Systematic sampling occurs and works rather nicely if you have an order relationship in the population being sampled. For example, if people are in line for some event, you see they're outside of a ticket window, for example, or waiting to get into a concert, something like that. So everybody is kind of in order to begin with, and we want a sample of, I don't know, 50 folks or something like that. Then what we might do is we'll say, okay, let's start at the beginning of the line and take every fifth person. So we could start with the first person or second, third, or fourth. You see, any one of those first 5 people as item number 1. And then the next item would be just count off 5, and that would be the next one. Count off another 5, that would be the next one. You see, that's what this systematic idea says. But we have to start with an order relationship to begin with, and then we take every 5th or every 8th or every 10th item until we get to the end of our sample, or the end of our sample size. Cluster sampling involves dividing the population into clusters, as the name implies, and then sampling everybody within a randomly selected cluster. Example would be, suppose we want to survey a random sampling of 5 corporations in the United States of a certain size. We identify all of the corporations in the United States that fit this size description. There might be 200 of them, let's say, or 2,000 for that matter. Let's say there are 2,000. And let's say we want a sampling involving 5 of them. Now, the cluster idea is that the corporations represent clusters. And what we'll do is we'll randomly select, we'll assign a number to all of those, let's say 2,000 corporations, and we will randomly select the number that we want of those corporations we want to sample, let's say 10. So we randomly select 10 corporations, and then we survey everyone within those 10 corporations selected. You see, we want, the whole idea here to begin with was to survey people in corporations of a certain size. And instead of randomly selecting people within all 2,000 corporations, what we do is we decide to randomly select corporations and then survey everyone within those corporations selected. So that's what cluster refers to. Convenience sampling probably contains the most bias of all of these and all of the examples that we've had before. Convenience sampling is, as the name implies, it's a survey according to convenience. What's easy? Well, what's easy is go outside the door and pick the first couple of people you see and survey them for whatever purpose. This is often done with the newscasters. They'll go to a site and they'll get an opinion of 2 or 3 people. Well, this is certainly not not a very random situation, is it? They're just surveying anybody that wants to talk on camera about a certain topic where they happen to be shooting. So bias is rampant in a convenience kind of sampling.